Good morning, my name is William McPherson. I'm a EE major here at VTC. My project was the Sonic leash and collar. I chose to go with that because I originally was going with sort of a pet idea, but I really didn't want to make a pet. I just wanted to make the leash and collar sort of aspect with radio transmitters, so I could apply it to something else. Just a little background on sonic sensors, from military to depth sensors, military sonar to depth sensors. They pretty much all rely on reflection of the wave. My idea was to use two different frequencies to communicate back and forth and not worry about the pulse back. So, sort of just like I was just saying here, this sort of is a pictorial that explains that. You get the 40 kilohertz coming off of the car, and the 40 kilohertz going back to, 24 kilohertz going to the person and 40 kilohertz coming back to the car. I'm looking for 4 or 5 feet for my nominal distance for what I wanted to stay at, and so I've calculated that. Speed of sound, 1,127 feet per second divided by 2. And my nominal pulse width range came out to 7.09 milliseconds to 8.87 milliseconds, respectively. This is just a block diagram of the leash circuit, its operation. It's got 24 kilohertz coming in. It's amplified by a factor of 1,000, and then it goes into the holy grail chip there, the tone detector, and through to the signal comparator. That when it's given a low signal from the tone detector chip will trigger the ATmega to go low as well. When that happens, the driver chip, the ATmega will pulse out a 40 kilohertz signal through the driver chip for amplification and back out to the collar. There's 2 push buttons here. The reset button's pretty standard for the ATmega 328. And the closer button is going to be to expand the amount of pulses that are sent out as a trigger, sort of like a data trigger for the collar. And yeah, it should probably look familiar. It's the same circuit pretty much, but there is a little bit of difference. Obviously, added the motor controller that the Kinetis board, which is different obviously than the 328. I'm using that to power the motors. And obviously the frequencies are reversed. This one is going to be powered off a 7.5 volt lithium battery. Also there, just for show, that's really going to be a port that comes into the board itself. And I've added a couple of infrared sensors off here for security essentially, so if my whole process starts to fail, I can stop it before it hits a wall or does whatever it does. And I separated the signals here a little bit. You can see the blue signals are coming to or are affected by the Kinetis board, the microchip, and the green ones are the ones being fed in. I didn't butcher that too bad. I probably should have mentioned on the other one, it's running off 3 AA batteries, not the 7.5 lithium. But I'm sure I've seen AA batteries before. I wanted to switch back. So this is the collar receiver. Basically, the point here is to get some sort of proximity to direction and which direction the person is traveling. So if you can imagine a wave hitting this is going to have a higher voltage than hitting this, at least at the first stage of amplification. I can't do it after the tone chip because they'd all be the same voltages for reasons I'll talk about later. But if the right one, from your point of view, has a higher voltage than the left and the middle, then well, I'm going right and vice versa. Okay, here's the leash schematic. The ATmega 328 is right here, and that goes through the driver chip, the MAX 3232. Coming in the 40 kilohertz gets amplified by the LM358 and onto the decoder chip and the comparator. So this chip right here, you can't really see it in this schematic too well, but it has a pull-up resistor coming off of the output, so it always sits at 5 volts if the signal isn't triggered. I'll just let you into that later, but again, probably it should look familiar. It's roughly about the same circuit. This is the collar. The only difference here, obviously, is the power supplies, the infrared receivers that I had to port out to the micro. And also with this, ideally in the future, I'd like to power both of them off the Atmega 328. And also just for troubleshooting, the 555 timer is here, added for the 24 kilohertz signal out, which is currently being produced by the Kinetis board. Some of these pinouts and stuff, most of them are just test. Right here is the adjustable frequency, gain, et cetera, et cetera. Okay, so this is the Holy Grail chip here. It is a tone detector chip, which is mainly used for, or was used, I should say, for frequency and amplitude modulation. Basically, it locks onto a certain frequency and goes low through a saturated transistor and pulls the pull-up resistor and the voltage supplying it down with it as well. The calculations here were pretty straightforward. This chip's amazing. It works extremely well. 1 over R1 C1 gives you your center frequency that you're aiming for. R2, sort of unneeded really. It sets the minimum input voltage for the chip, which, you know, if you're like 20 feet away, you know, you might get a signal that's lower than 10 millivolts, but probably not. Anyways, it was added in there obviously for safety reasons and practicality. I don't want my car blowing up. C3 and C2 set each side of the bandwidth, and that's to avoid false triggering. They're pretty standard. I used a 0.01, which was recommended, and I used a 0.02. Sorry, so 0.01 for the 40 kilohertz and a 0.02 for the 24.5 kilohertz. I'll go for that one. This is the TTL driving circuit. It's basically just that. It's a driver circuit. It amplifies the signal. It is sort of interesting. It runs off a 5-volt supply, and it uses these 4 capacitors as charge pumps to provide a 9 to 12 volt output signal off just a couple of volts or even less than that. So this is the function that I wrote for the Kinetis program. I was going to add the other one in here, and honestly, this looks fine, but on my TV at home, you couldn't see the program very well at all. So basically what's going on here is that I'm setting the output frequency of the Kinetis board. It goes through a prescaler, which, a pre-prescaler, which brings the 48 megahertz down to 24 megahertz. I could be clearer on how that does that, but from here on out, I'm pretty good. So the 24 kilohertz gets divided by the prescaler, and then the modulus. The prescaler comes in your 2, 4, 16, 32, 64, etc. And the modulus is 0 to 15 bits, which is like 6,000. Anyways, all that is to say is that the Kinetis board has a much wider frequency range than the 328. So, yeah, what I've done here is, so you can see by the notes, I clear the register, set it to 0, and start sending the 24 kilohertz. I delay 1 millisecond, which is quite a few pulses. I'm not so worried about the 40 kilohertz signal as I am the 24.5, because it's the one sending signals back for data. And then I stop sending. This was new to me, the Arduino software. It's much easier, but still it's a little bit of an uptake. So what this program does is essentially what I was just doing with the Kinetis board, just in really with just different commands. So basically, ORing these two together allows the micro to trigger at this number, which is 195, and that brings me down to the 40 kilohertz range. Also, I have for the reading pin for the chip, in order to like get around the low battery thing and having false triggers based on low battery, I chose to go with an analog input that reads the voltage, so I can always sort of set that or at least sort of keep up with it as the batteries go down. So up here, you set your code just like we did in micro, where you set the range from 0 to maximum voltage and scale it back for the signal that's coming in. And so, down here I have, start sending the signal if the voltage is less than 4 volts, and pin 11 starts putting out the 40 kilohertz signal that is derived just here. So yeah, the function here is 16 megahertz, which is the oscillator that's hooked up to the Atmega chip on my schematic, which I probably should have pointed out. And that's divided by 2, and then divided by 195, which brings me just down to about 40 kilohertz. List of issues, there were many. I had sort of an embarrassing one with an H bridge. It started shorting in between the switching cycles, and even more embarrassingly enough, I didn't use matched transistors for it. The guy didn't, that I was looking at the schematic, but I guess it worked for him. Noise is pretty much a problem at every aspect of this project. It's where you mount the receivers and the transmitters to the voltage that's going to be present at the comparator versus at the microchip. Everywhere. Frequency limitations, I sort of jumped the gun on that and already went into it. The Atmega 328 doesn't go low enough. It pretty much maxes out at the lowest frequency it'll put out is about 32 kilohertz. So I sort of got lucky that it met the 40. I needed a boot chip. Honestly, this was like God himself. I was researching it. It took about like 8 seconds, but if I didn't read, or I think possibly, it might have been mentioned to me before, you have to have a boot chip that's in the Atmega so you can program it, so you can take it off the Arduino, plug it into your circuit, and run it like you would a normal micro. And early on, I tried doing this with bandpass filters, and it worked, but with the two of them pointed at each other, it was better. It was insane. You just couldn't keep the noise away, and you get false triggers all over the place. So this is my end product. A little bit of a cop-out. I haven't gotten mine to the point where a picture would do any justice, but it is going to be done by the end of the week. And so, basically this is just sort of a picture of something that already exists that fits the application. This thing can follow you. This is meant more for, the walking aspect of it. Mine is going to run on wheels. And the remote. Might have been able to do a little bit of a better job there finding a picture of a remote that was more applicable, but I think you all get the idea. Social responsibility. Low power consumption as an end result. When I hook the other 328 mega up, if I'm able to run the motor controller off of it, which we will see, then I probably could get down to acceptable power levels. Product reliability is just that sort of the same thing I was talking about with the noise, making sure that it's not false triggering under any circumstances, because I can't, or at least right now, run the sonic sensor with it, because it's at 40 kilohertz, so it really is just traveling blind, hoping that it's going to follow me. If it doesn't, then something could go wrong. It's also the same reason that the IR sensor is being used still. Self-cleanup, when you put it on a toy, ideally it never gets lost unless your kid loses the collar, or sorry, the leash. Digital companionship, not that kind. And resurrection of ultrasonic technology. I've just sort of been realizing, they have all these other means of how to do this out there, the optical drive and lasers, and they're much better for certain applications, but radio sensors, let's just put it this way, you won't want to point lasers at each other and be on the receiving end of that, and you're essentially pointing two video cameras from one end to the other is extremely costly. It doesn't really get you anything, but I feel as though sonic waves sort of fit in that niche. On to the awkward part. So yeah, I'd just like to take this time to thank you guys, especially you, Mr. St. Dennis. You're always here till like ungodly hours at night. You can apologize to your kids for me, I'm sorry. Mark Correo, great guy, just best at explaining things in plain English. Dave Jarman's the best at understanding op amps, especially when it came down to trying to dissect the ultrasonic sensor. Bob Royce, why that guy's hit me, I don't know. And Star Child, man, just illuminating my life, can I say?
Who's Mark Correo?
Serious?
You've never had Correo?
I'm gonna wait till the camera goes off to ask if I'm correct on that, I'm pretty sure. Anywho, questions?
My wife actually runs it through in there.
Back on the Arduino software. So you start the transducer and then you do a delay. Are you missing a line there to stop the transducer? Am I missing?
You know what, I am actually. I'm missing that down here after the delay. I'm not gonna lie, I realized that about 10 minutes before I came up.
And if you go back to the caller receiver, the three element one,
3-element one?
that one right there.
Oh, okay.
So, were you saying this is a future thing, or did you build the three elements into that circuit that's on the previous slide? Are you building that, the three of them? Or you just saying?
Yes, sorry, actually, I didn't mean to mention that. I'm building this one right now, but, you know, as I sort of pointed out, all the circuits the same. So once I get this working, printing another one will be easy and, you know, be able to do both. But I have built the block, not that impressive, but the block is there. I have to use this, otherwise it's really limited in what I can do right off the bat.
Okay, so what are those wires on the top, really? Is it just three wires? Can you go to the collar schematic and show me where those wires tie in?
Okay, sorry, can you just go back to that one? No? Yeah, that one, that's one you can probably check. Okay, so, you know, you're talking just power, output, and ground.
Oh, okay. And is the output like a pulse width output, like in the regular sonic, or the ultrasonic sensor? Is that, when you say output, what's output?
Yeah, it's the incoming signal. So
Okay.
it'd be, yeah, it'd be the incoming
So
signal.
those wires go to, okay, is it three wires?
Yeah, I mean, they're there for looks, but yeah, they, you know, we'll just say
So where would those go?
positive, negative signal.
Okay. So-
Oh,
Okay.
how?
So how is that gonna?
I correct myself.
All right.
Each one is for the output, and I didn't show the power and ground.
Okay. So you need to specify 3 pins on your micro that you're gonna use to receive these, right?
Yep. Which,
Which you don't, I don't think you have in your schematic.
yeah, you know, I might have skipped over that. Can you go back? No, you're right there.
That's the leash. You want the collar scan.
Oh, yeah, I'm sorry. Okay, so right here, I have the compare, and you're right, I would need 2 more when it comes down to it, but it's gonna be on a different circuit too, so. I could have put the signals coming out on the other schematic from the other board.
Okay. Well, these are gonna be pretty small boards. These aren't add-on boards to your micro or anything, right? These are separate little boards, like the buck loose boards that the other guys are doing.
Yeah, exactly, they're probably gonna be mounted on the back of that block, close to it.
Okay.
Mr. Brett,
Mr. Brad. I'm gonna call that.
hand getting tired?
Is there an adjustment on there so you can adjust the range that you want to like limit the pet
So going back and forth, you mean like correcting
Like
itself?
the
within
range,
the-
how far away can it be from you?
Yeah, well,
Or is it just gonna follow you until it like comes right up to you?
No, it's gonna stay in that 4 to 5 foot range that I was saying in the beginning. And I didn't, what I put up there was the function that you declare, and not my main program, because I had it in the RoboCar software. I probably should have, honestly, it just didn't when I was looking at it last night. But anyways, yeah, there is a loop. You know, if it's higher than 7.78 milliseconds, then, you know, it'll increase the speed, and if it's lower than 8.83, it'll decrease the speed with the pulse modulation software we use for the servo.
Could this be mounted on like a shock collar and used on an actual animal?
That'd be mean.
It could,
You
and
could
they
run-
already
There
make
would be
them.
like a beep warning. If you start to exceed it, it'd be like a regular shock collar where it gives you a warning, hey, beep, 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 you better catch up to your buddy walking over there.
It could, and they already do, sort of, you know, they use them for like automatic feeders and stuff. They actually use ultrasonic sensors to ward away dogs too. They like put out a really high frequency, like a cat's dish sort of thing. But yeah, I mean, that's sort of why I went with the leash and collar idea too. Is you know, the idea is you can put this on something else, and theoretically anything that you can control via micro that can propel itself. Anybody?
All right, thank you.
A little louder, man, huh?